Hey guys, so welcome back to yet another video. In this video, we'll be trying to solve the problem of the day of 6th January, that is Techfest and the queue. Okay, a Techfest is underway and each participant is given a ticket with a unique number. Organizers decide to avoid price points to everyone who has a ticket ID between A and B inclusive. The points given to a participant with ticket number X will be the sum of powers of the prime factors of X. Okay, and now here's a follow-up. And they also gave you a few examples to refer. So in this, the basic idea of this question is that you have to basically add the prime factors of all the numbers that occurs between A and B, okay, in simple words. So I'll try to explain that a bit better. So over here, all right. Now, before I get on to the problem, I have a few things to say, okay. The prime factors of a number, okay. So over here, say for example, our number is 80. Okay. Say for example, our number is 80. One thing to note is that you can never have a prime factor that is more than half of the number itself. Okay. Now the reason I'm saying this is, say for example, I take a number called 14. Okay, like 14 will make more sense. Okay. If you take the half of 14, it is 7. Now 7 is a factor of 14. Okay, because 7 into 2 is 14. Right. As I said, there is no number more than half of a particular number. That is its factor. So from 8 you check. 8, 9, 10, 11, 12 and 13. None of them can divide 14. Okay, you have to always remember that. So while checking for prime factors, instead of going from 2 till 14, we can just go from 2 till 7, right? We can just go from 2 till 7. Because after 7, we know for a fact that there is no number which can divide 14, right? So just keep that in your mind. We'll be using that later. Okay. So now let's say, for example, our A is 14. Okay, I'll start with like 14 itself. And our B is 16. Okay. So firstly, we'll have a for loop. We'll have a for loop going from A to B. Okay, so we'll get 14, 15 and 16 from this for loop. Okay. So I'll explain the basic logic behind this. If you check for 14, the prime factors are what? 2 sevens are 14, 7 ones are 7. So for 14, you have 2 prime factors. The easiest way to find the prime factors is just by finding the LCM. Okay. Now after 14, you have 15. The prime factors of 15 are 3 and 5. Again, you have 2 prime factors. Then go to 16. For 16, you have 2, 8, then 2, 4, 2, 1, and 2, 2, and 2, 1. You have 4 prime factors. So your answer should basically be 8 because 2 plus 4 will give you 8 as the answer, right? So you're basically supposed to add all the prime factors and display that as your output. Okay, so back to our loop. We'll have a for loop going from A to B. Okay, now this will be your I loop, of course. This will be your I loop. Then we'll have a for J loop inside this, which will divide our existing number with every prime number to check if it is divisible or not. So it'll go from A to B. So I'll just keep a variable called, let's say, num. Okay, so like num in the beginning, it will be 40, then it will be 15, then it will be 60. Basically the same value as I. Okay, so for J, we'll start from J is equal to 2. Okay, we'll start from J is equal to 2. We'll go only up till J star J is less than equal to num. And we'll do J plus plus. Now here, as I said, we are doing J star J less than equal to num because, as I said, say for example, you have 14. And half of 14 is 7. Right? Half of 14 is 7. There is no number above 7 that can divide 14. Okay, there is no number above 7 that can divide 14. So this condition basically checks that. Okay, So like, say for example, you have 7 itself. Okay. 2 into 2 is 4. Right? 2 into 2 is 4. And 3 into 3 is 9. Now 9 exceeds 7. So after 3 up till 7, there is no other number which can divide 7, right? Like it's basic common sense. So yeah, now this condition satisfies that. Now apart from that, we will have a while loop inside. Okay, while let's say num mod j is equal to 0. Now this is basically to check if it is divisible by the number or not. If it's equal to 0, we'll just do j slash equal to, num slash equal to j, and we'll increase 1 to answer. Now answer variable in the beginning, it will be 0. Okay, because in the beginning we will have found 0 prime factors. Okay, so let's start. Our starting number is a is 14. That 14 will be stored inside num. Okay, so num, right now you have 14. Let me choose a different color. Okay, num, right now you have 14. Okay, now we'll just do j is equal to, of course j will start from 2, and it will satisfy this state. Okay, because 2 into 2 is 4. 4 is less than 14, so we are good. Now while num mod j is equal to 0, now 14 mod 2 is 0, right? So what we'll do is we'll divide 14 by 2. Now 14 will come to 7 because 14 by 2 is 7. And we'll add 1 to answer because we found one prime factor, that is 2, right? Because 2 divides 14 to give 7. So from here, answer from 0, it will go to 1. So here j from 2, it will go to 3. Now 3 into 3 will give you the answer as 9. Now 9 is more than 7. Okay, 9 is more than 7, so we can be sure that from 4 up till 7, there is no number that can divide 7 as such. Okay, so, but if you think about it, 7 can divide 7. Okay, a number is its own biggest prime factor in some cases. Okay, so here if you think about it, you have 7 here. 7 can divide 7. Now this for loop won't accommodate for that exception. So what we'll do is we'll exit the for loop and we'll just check if num is more than 1 or not. This num is more than 1, we are just checking as if it is a prime number or not. That's it. Okay, now 7 is more than 1. So we'll add 1 to answer. So then now the value of answer is 2. Right? Now the value of answer is 2. Now we already found the 2 prime factors of 14. Right? We found 2 and we found 7. Okay. Now we'll move on to 15. Now we'll move on to 15. So let me just erase this. Now even for 15, we'll follow the exact same step, right? We will have 15 first, j is equal to 2. First j will be 2. 2 won't go in 15, right? Then j will again go forward. 3 will go in 15. So you divide 15 by 3. 15 gets updated to 5. And you add 1 to answer. Now the value of answer is 3. Okay. Now after this, you check for 4. Okay. Now 4 4s are 16. You are checking if j into j is less than or equal to num. After 3, it will go to 4. Now 4 into 4 is more than 5, right? 4 into 4 is 16. That's more than 5. So we'll exit out of the loop. Again, 5 is its own prime factor. So we'll satisfy this condition if num is more than 1, and the value of answer will go to 4. Okay. Similarly, we'll check for 16. Right. Now 15 is over. Now we'll check for 16. Now we're checking for 16. Now this is actually the easiest because j is equal to 2, right? 2 will go in every factor of 16. So we'll go inside the while loop. 16 mod 2 is 0, right? Now 16 will be 8. We'll add 1 to answer. Now from answer from 4 will go to 5. Again, 8 is again divisible by 2. 8 will go on to 4. We'll again add 1 to answer. So from 5 it will go to 6. 4 is again divisible by 2. From 4 it will go to 2. We'll again add 1 to answer. Answer will be 7. Then 2 is again divisible by 2. 2 will go to 1. And we'll add 1 to answer, which is 8. Okay, now this is your final answer, 8. Now if you see here, your last value of num is 1. This condition won't be satisfied because num is not more than 1. Num is 1, right? So this means we already accommodated for all the prime factors of num. So now our final answer is 8, which we can display. All right. Now let's see how we can code the solution out. Okay, so let's code the solution out for this. Now we'll start with answer equal to 0. Then for int I equal to a, I less than equal to b, and I plus plus. Okay, we'll just keep a variable called int num, which will be holding the value of the I variable. Okay, then for int j equal to 2, j less or j star j, because we have the special condition which we talked about. This is just for more efficiency. All right, less than num j plus plus. Now while num mod j is equal to 0, that is if it is divisible, then we can just divide num with j and we can add 1 to answer. Now after this we get the exceptional case. If num is more than 1, that is if a number is its own prime factor, we can add 1 to answer and we can continue, right? Then at the end we can just return answer. Now this should work. Let's run and see. Forgot. Okay, one semicolon here. Let's see. There you go, it works. Let's submit. And there you go. That's how you solve this problem. If you have any doubts, do leave them in the comment section down below. The link to my GitHub repository will be down, which has this code inside of it. So yeah, that's it for this video. Don't forget to like and subscribe, and I'll see you in the next one. Bye.